and we're going to continue our lesson on the basics of transformations. We're now talking about congruence and orientation.
Congruence, that is a vocabulary word that you are going to need to remember, okay? So congruence refers to whether or not a figure has the same size and shape after a transformation.
Orientation of the figure refers to, got to hold with me, I'm writing, refers to whether or not the figure is facing the same direction on the coordinate plane after the transformation.
Orientation of the vertices, so that is your point, refers to the order in which the vertices are labeled, clockwise or counterclockwise.
And we'll talk more about the counterclockwise and clockwise when we get into rotations in a few more lessons. So down here we're going to practice. It says label the type of transformation shown, then state whether the size and orientation changed or stayed the same. The first one, we need to figure out what happened here, Ms. Carrazzo.
All right, so if I drew a line between those two triangles, it looks to me like that shape was just flipped over the line. It looks like a mirror image. I would call that a reflection.
Ms. Carrazzo, how do I know which one was the first image and which one was the second image?
So the original image, which is the pre-image, is going to be the figure on the left. The image is your new figure, and that is designated by the little apostrophe after each letter. That is what we refer to as prime.
So, did the size change or stay the same?
The size looks the same to me.
The orientation, I think that changed because on this one, my C is on the right side of the figure, and on this one, my C is on the left side. So that changed.
The orientation of the vertices also changed.
All right, you ready to move on?
Sure.
What happened on number 2?
So if I draw my line between the two triangles on number 2, it looks like the triangle just slid to the right. So to me, that is a translation or a slide.
All right, did the size change or stay the same?
The size looks the same to me.
Orientation.
It looks like the C is on the right side in both triangles, so that would be the same again.
And last, the orientation of the vertices.
They look the same too.
And guys, what that means is you go from A to B to C. You still go from A to B to C. That's why it stayed the same. Oh, look at this transformation.
Well, this transformation has a triangle that is a different size. And the only transformation with a triangle or with a shape that is a different size is a dilation.
So we have our pre-image and our image.
Again, designated by the prime after the letter on each vertice.
And this size changed.
And if we want to get technical, we would say it is a reduction because it got smaller.
The orientation is the same.
And the orientation of the vertices is the same.
All right, last one.
Well, there's only one more left, but if I look at it, it looks like the image is flipped upside down. I would call that a rotation.
Okay, the size is the
Same.
The orientation of the figure.
It's changed. The B's on top and B prime is on bottom. So that shows me that the figure is turned.
Now, for orientation of the vertices, it still goes from A to B to C, and over here it's A, B, C. So those actually stayed the same.
Even though they look different, they stayed the same.
If you have any questions, please send us a screenshot or an email or a message on Canvas, and we will get back to you as soon as possible. You can send that to Ms. Razzo or Ms. Davis. Thank you so much.
Bye, guys.